Venus, Earth's twin in size, but a hellscape now. Could life have started there anyway? Over the next 5 minutes, we'll trace Venus's history, the cloud-habitable idea, dramatic chemical hints that shocked astronomers, and why new missions could answer the question once and for all. Today, Venus is extremely hostile. Surface temperatures and pressures that melt most Earth life, and clouds of concentrated sulfuric acid. But habitability is about history. Could Venus once have been more temperate, with water where life might have begun? For decades, scientists have proposed that early Venus might have been cooler and wet, perhaps an ocean for tens or hundreds of millions of years. If so, that would open a window for life to arise. However, recent studies analyzing volcanic emissions and interior water signatures argue Venus may never have had long-lasting surface oceans. Instead, its interior appears very dry, which weakens the ocean scenario. Even if the surface was never hospitable, Venus's middle cloud layer is surprisingly temperate. Pressures and temperatures there can be Earth-like. That led scientists to propose airborne microbes living in droplets of less acidic microenvironments inside the clouds. In 2020, a team reported traces of phosphine, a gas associated on Earth with anaerobic life, in Venus's clouds. The claim energized the field. Phosphine is hard to produce abiotically in an oxidized planet. But the detection and interpretation proved controversial. Reanalyses questioned the signal. Alternative identifications like sulfur compounds were proposed, and later studies have both challenged and partially corroborated the presence of unusual gases. Even if microbes existed in clouds, could the building blocks survive? New lab work finds many amino acids remain surprisingly stable in strong sulfuric acid environments, longer than expected, suggesting that some organic molecules might persist in cloud droplets for days to weeks, potentially allowing chemistry to occur. Phosphine or other unusual gases might be produced by unknown chemical pathways, lightning, volcanism, or exotic photochemistry in the upper atmosphere. Abiotic production cannot be dismissed yet. The truth is, we don't have conclusive causal chains connecting Venusian chemistry to life. That's why more direct measurements are crucial. NASA and ESA are sending missions that will finally give direct answers. Da Vinci will sample the atmosphere and measure composition in situ. Veritas and Envision will map the surface and its geologic history to determine whether stable water was ever present. These missions, planned in the early 2030s, will move the question from speculation to data. A single gas would not prove life. We'd need multiple independent lines of evidence: complex organics, isotopic signatures, microstructures consistent with biology, and atmospheric context that rules out abiotic pathways. Could life have started on Venus? It's possible in theory, less likely by some recent evidence, but far from settled. The next decade will tell us whether our scorching neighbor hides an airborne biosphere or a fascinating chemistry we still don't understand. Keep wondering, keep learning. MindSeedWorld.